Have you ever looked up at the night sky and wondered what you're really seeing? It's not just a beautiful collection of twinkling lights. It's a history book, a cosmic archive written in light, and tonight we're going to learn how to read it. Right now, we're surrounded by the dazzling cities of stars we call galaxies. Spiral arms, glowing with the birth of new suns, stretch across millions of light years. Elliptical galaxies, ancient and golden, house trillions of older stars. Nebulae, the cosmic nurseries, are vast clouds of gas and dust, illuminated from within by the brilliant, short-lived giants they've just created. Every single point of light, from the faintest glimmer to the brightest beacon, is a star system, a galaxy, a story. This is our cosmic neighborhood, the universe as we see it today. It feels immediate, present, and alive. But there's a secret hidden in plain sight. The light from these celestial wonders has traveled an immense distance to reach our eyes. Take Andromeda, our closest major galactic neighbor. The light we see from it tonight actually left its source 2.5 million years ago. We are seeing Andromeda not as it is now, but as it was when early human ancestors were first walking the Earth. Light travels incredibly fast, about 300,000 kilometers per second, but space is unimaginably vast. So the farther away we look, the further back in time we see. Now let's take a journey. We're pulling back from our local group of galaxies, watching as Andromeda and the Milky Way shrink into tiny specks. We're moving faster than light could ever travel, across voids of seemingly empty space that stretch for hundreds of millions of light years. Clusters of galaxies, once looking like sprawling continents, now resemble a delicate shimmering web. We're crossing billions of light years in seconds. Out here, in the profound emptiness between the great cosmic structures, we can see it, faint, ancient streams of light. These are photons, particles of light, that have been on a solitary journey for an almost eternal stretch of time, carrying with them a picture of a universe that no longer exists. They are time travelers, and they are our guides to the distant past. What happens if we keep looking further and further back? Past the galaxies we know? Past the most distant quasars burning at the edge of the visible cosmos? If we could strip away all the stars, all the galaxies, all the dust, what would we see? We would see a wall of light. Not a bright, blinding light, but a faint, almost imperceptible glow, filling every direction of the sky. This is the cosmic microwave background, or the CMB. It's the oldest light in the universe. This is the afterglow of the Big Bang itself. This faint radiation is a snapshot of the universe when it was only 380,000 years old. Before this, the universe was a hot, dense, opaque soup of plasma. But as it expanded and cooled, atoms formed, and for the very first time, light was set free to travel unimpeded through space. That primordial light has been traveling ever since, stretching and cooling over 13.8 billion years until it reaches us today as a faint microwave whisper. The CMB isn't uniform. It has tiny temperature fluctuations, minuscule variations shown here as patterns of color. These subtle differences are incredibly important. They are the seeds from which all cosmic structure grew. The slightly denser, cooler spots were the gravitational anchors that would eventually pull matter together to form the very first stars and galaxies. So how do we read this ancient message? It takes incredible ingenuity. From the highest, driest deserts on Earth to sophisticated satellites orbiting high above the atmosphere, scientists build remarkable observatories. These telescopes are our time machines. They collect the faint light from distant galaxies and the even fainter microwaves of the CMB. This light is then funneled into powerful computers where researchers and astrophysicists work to decode the information it carries. They analyze the spectrum of light to understand what ancient stars were made of. They measure its redshift to calculate just how far away, and thus how far back in time, they are looking. By carefully studying the patterns in the cosmic microwave background, scientists can run simulations, like the ones you're seeing now. These models show us how those tiny initial fluctuations grew under the influence of gravity over billions of years. We can watch as dark matter forms a vast, invisible scaffold, and ordinary matter is drawn into its web, igniting to form the first generation of stars. These were true giants, hundreds of times more massive than our Sun, living fast and dying young in spectacular supernova explosions. These explosions seeded the universe with heavier elements, the very elements that make up planets and even us. It's an incredible process, a story of creation written in the language of physics, and we've learned to translate it. So, let's put it all together. Every time you gaze at the night sky, remember what you're truly witnessing. You are not seeing a static image. You are looking at a deep, layered history. The moon is just over a second in the past, the sun about 8 minutes. The nearest star, Proxima Centauri, is 4 years in the past, the Andromeda Galaxy, 2.5 million years, and those faintest, most distant galaxies captured by our most powerful telescopes. We see them as they were over 13 billion years ago, when the universe was just a toddler. And behind it all, permeating everything, is the echo of creation itself, the cosmic microwave background. The universe isn't just a place, it's a record. It's a vast 4-dimensional archive containing the complete story of its own existence. The light reaching us today is a continuous stream of historical data, from the dawn of time to this very moment. By looking up and looking out, we are looking back. The cosmos is the ultimate history book, and we have only just begun to turn its pages. Thank you so much for joining me on this journey through cosmic time. If you found this as fascinating as I do, please hit that like button and subscribe for more adventures into the mysteries of our universe. See you next time.